emergency above the French Alps strikes Transair Cargo Flight 671.
There was an enormous bang, and the aircraft almost inverted.
Mayday! Mayday! Mayday!
The crew needs to land, but are flying blind.
Cargo 671, we have no radar contact.
They stood a very real chance of hitting a mountain.
Then they discover something even more horrifying.
I saw nothing in the number 4 engine position. The wing was clean.
Assuming the worst, the first officer leaves a clue for investigators.
I took the photograph because I wasn't sure what would happen next. If somebody might find the camera, they'd see the truth.
Transair Flight 671 is preparing for takeoff at Luxembourg Airport.
Forecast says we'll get some weather in an hour.
As we cross over the Alps. Typical.
Captain Ingemar Berglund is a highly experienced Swedish pilot who has been flying Boeing 707 aircraft for over a decade.
The captain had been a military pilot, and then he'd been on air transport flying for most of his working life. His experience was pretty vast in Africa and in Europe. He knew the routes, and he was a very good pilot.
Cabo 671, you are cleared for takeoff. Runway 24.
671, cleared for takeoff. Roger.
First Officer Martin Emery is an accomplished British pilot who has worked as an instructor and an air traffic controller.
Ready to go.
The first officer had about 10,000 hours, about half of which was on the Boeing 707, so he was very experienced too.
V1. 170. Rotate.
The Boeing 707 is a long-range aircraft powered by 4 Pratt & Whitney engines.
It was a very basic aeroplane, very strong, very reliable, and could carry 40 or 50 tons of freight.
Assisting the pilots is flight engineer Terry Boone.
The Boeing 707 didn't have much in the way of automated systems, but this meant that there was a whole panel sideways in the flight deck in which the flight engineer had to operate every system manually.
He was probably one of the most experienced Boeing 707 flight engineers in the world.
Today's flight is a 7-hour journey from Luxembourg to Kano, Nigeria.
Feels a little heavy today.
Well, do you see what's loaded back there? It's all oil well equipment.
Yeah, not the light kind.
Flight 671 is operated by the newly formed Nigerian company Transair Limited. Their client, Cabo Air Cargo.
Transair had only been formed a few weeks before this incident. It was purely for the oil industry to transport a lot of equipment down to Nigeria for the oil works.
This was an extra special flight in that it was carrying equipment that would have helped Nigeria in their modernizing.
Cabo 671 levels off at 29,000 feet.
The flight plan indicated with the weight of the aircraft, we should stay at a slightly lower than normal flight level for the first part of the flight until we burned off fuel, and then we could gain a higher flight level.
How are the guys in the back?
Good. He made us coffee.
Also on board are a cargo supervisor and a maintenance engineer.
Like them more every day.
So the 5 of them were knowledgeable about the 707 They were knowledgeable about this sort of ad hoc air cargo work. Although they hadn't met until a fortnight previously, I think they worked well together as a team.
Over the Alps, the weather deteriorates.
Pretty much ground level up to about 33,000 feet was in cloud, and the cloud was rough and turbulent.
Gonna buckle up until we're above it.
Good idea.
We engaged our 5-point seat harness rather than just the 4-point harnesses that we normally keep on to the top of climb, and then moved our seats forward to be really guarding the controls in this turbulent air. It was getting quite rough.
Ask if we can go to 3-3.
Cabo 671.
Request flight level 330.
671, roger. Climb to
Flight level 330.
Climb 330, 671.
The requested climb was to go up another 4,000.
One hour into the flight, just as the plane reaches 33,000 feet.
There was an enormous bang, followed almost immediately by another one, and the aircraft absolutely rolled to the right.
The captain uses all his strength to level the plane.
Had the captain not reacted as quickly as he did, the aircraft could have rolled over, in fact inverted.
Engine fire!
Engines 3 and 4 show signs of fire. While the flight engineer deals with the engine alarms, the first officer checks on the engines.
I saw nothing in the number 4 engine position.
Number 4 engine has left the wing. Mayday, 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 cover 671.
With reduced engine power and an unbalanced configuration, the flight drops out of the sky in an uncontrolled descent.
The descent rate was horrific. I think I saw 8,000 or 9,000 feet per minute.
It's diving quickly towards the French Alps through heavy cloud.
They need to get out of the mountains, and they can't see outside because of the thick cloud. They need the air traffic controller to give them a direction in which to head for a safe haven, for a safe airport.
Mayday, 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 request descent for radar landing.
The ground service can follow your track over the ground, your heading, your height and speed. From our transponder, they can point you to the nearest available runway.
But air traffic control has bad news.
Bravo 671, we have no radar contact. Say your position, please, sir.
They can no longer see Flight 671 on the radar.
With nobody able to give them a direction to steer, they stood a very real chance of hitting a mountain.
The plane's radar transponder has failed.
I was considering which direction we could go to avoid the mountains. It was very scary.
The situation is dire enough that the first officer records the damage to the wing.
I wasn't sure what would happen next. I believe that if anything ended, like the flight before we were ready, somebody might find the camera and then they'd see the truth.
Flight 671 is in an uncontrolled descent over the French Alps. With thick cloud and no transponder for the controller to guide them, the crew is flying blind.
Mayday, 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 request descent for radar landing.
The flight engineer attempts to get the transponder working again. He suspects there is a power issue.
The reason the air traffic control lost the radar initially was probably because the electrics powering the radar failed when engine number 4 fell off.
The flight engineer redirects the power to engine 1.
You selected the essential power selector to engine number 1, which had an operative electrical generator.
It works.
Request descent, radar landing.
Roger. Turn left heading south to Marseille.
The controller directs Flight 671 to Marseille Airport, 75 miles away.
You turn left 180.
Okay.
There was immense relief as they descended out of the cloud and finally could see the mountains around them.
But relief is short-lived after the first officer gives the right wing a further inspection.
We've lost both engines on the right wing.
What?
With a 5-point harness, you are slightly restricted, but I did manage to look right over my right shoulder, and both the engines were off the wing. The wing was clean, which was a really big shock.
We've lost both engines.
Both engines?
Just about the worst thing that can happen in an airliner is to have an engine depart from the aircraft. The only thing worse than that would be to have 2 engines depart from your aircraft.
With only the 2 left engines functioning, control of the plane is compromised.
When you've lost both engines from the right wing and still have a lot of thrust from the engines on the left wing, it upsets that balance and causes the aeroplane to turn and to roll very powerfully to the right. Getting the airplane to turn left is a huge ask under these circumstances.
You turn 180?
Yeah. I'm trying.
Flying the disabled plane is testing the captain's strength.
The Boeing 707 has all manual flying controls. It's very heavy to fly when everything's working well. When you've lost 2 engines on one side, it's virtually at the limit of physical capability for the captain.
Want to dump fuel? Yes, dump fuel.
To keep Flight 671 in the air, the crew decides to reduce its load.
This aircraft was carrying a very heavy fuel load, and it was imperative to reduce that fuel load.
But it requires a precise calculation. They need to leave themselves enough fuel to reach Marseille and land safely.
112 tons is the maximum safe weight at which they can land. If they're any heavier than that and hit the ground hard, they would be sliding along the runway on their belly, shedding fuel and burning. This is not a position you want to be in.
The process is time-consuming. As Flight 671 completes its left turn towards Marseille, Captain Berglund reduces power in the 2 left engines.
They had to reduce the power on the left engines to give themselves a chance of staying upright and going in the direction they wanted to go in.
Reducing airspeed means an increase in the angle of descent.
Unfortunately, this of course meant they then descended more rapidly. They have to land soon, and they have to land somewhere very nearby.
Airspeed isn't the crew's only concern.
Request the weather.
Give me the weather for Marseille, 671.
I really needed the weather at Marseille to make a plan for an approach to land, either direct or a circuit or whatever we could do.
But air traffic control isn't responding.
Request weather.
Mayday, 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 671. Request weather.
It was quite a tough call to actually get the instant weather at that moment at Marseille Airport that we needed right now.
Making matters worse, the fuel dump is not going as expected. Fuel tank number 1 isn't discharging.
It became evident to the flight engineer that the number 1 fuel tank wasn't emptying. This would cause a lateral imbalance across the airplane, which is not a good thing.
I've got limited maneuver. You dumping?
Yeah.
The flight engineer discovers that a circuit breaker has popped.
By pushing the circuit breaker back in, he was able to reactivate the number 1 fuel pump and get the fuel jettisoning from all 4 tanks simultaneously.
Flight 671 is 30 miles from the runway in Marseille.
Mayday, Mayday, Mayday.
Non, oui, je comprends. Oui, non, c'est pas bon. Merci. It's raining on the airfield. 2 octa stratocumulus, 500 feet.
3 octas cumulonimbus, 1600 feet. 3 octas cumulus, 2000 feet.
Oh, no, no.
Thunder clouds and the risk of turbulence will make a difficult landing harder.
We were pushed to even get there with the height available, and with thunderstorm activity, it was really a no-go.
Cabo 671, what is our distance to the runway?
22 miles per landing, sir.
We had no plan B at that point. That was a nasty moment. What we wanted was a runway, and we wanted it quickly.
Hey, you see the airfield?
I don't see it.
Flight 671 is in a rapid descent with limited maneuverability, less than 9,000 feet above southern France, when the crew finally gets a break.
I looked through just cloud underneath us, and I glimpsed some ribbon black tarmac. It was a runway.
Cabo 671, we have an airfield ahead. What is that airfield?
It's a military airfield at your 12 o'clock.
For 6 miles.
Can we land there?
No, it's too short, too short.
How long is the runway on this military airfield?
13,000 feet.
Oh, yeah. Okay.
The runway at Istres is long. It is France's flight test center, and it was also a space shuttle alternate learning ground. It's probably the biggest airport in Europe.
Military airfield, Mayday, traffic 671.
The first officer makes contact with air traffic control at Istres Airport.
671, this is Istres. You are cleared for arrival. Runway 33.
We're just overhead. What's the wind?
Wind is
330, 10 knots, gusting 1 to 4 knots.
We'll make a left-hand pattern from the west.
Yeah.
The French military air traffic controller was one of my gang. I thought he was great.
We turn left to land.
Yes. As they start their turn, the crew lowers the plane's flaps in preparation for landing.
The wheels were down and locked, and the flaps were coming down, so Captain Berglund could have more roll control.
But when the flaps are extended, disaster strikes.
There was another big explosion, which tried to roll us right again.
Turn left. Turn left to land. Turn left.
I'm trying.
Turn left to land. Left turn.
Yeah.
Oh, we missed the runway.
They're unable to line up for landing.
S22E04, we have fire on board. I confirm, fire on board.
I could hear the fire, but I didn't say anything.
We need another runway.
Take a runway 15. Wind is
320, 10 knots, cleared direct.
After failing to make a hard left for a landing on runway 33, the crew attempt to circle back and land on the runway's opposite end, known as 15. The captain doesn't have the strength to make the turn on his own, but the first officer has an idea.
I said, "I'll take the power," and Captain Berglund said to me, "Be careful." I said, "I will, I promise."
The first officer adjusts the throttles to help steer the plane to the runway.
And bringing back number 1 and advancing number 2, it actually turned the airplane left and he could fly it going towards the runway, which was a miracle. Truly was.
It's a race against time to get the plane on the ground before the wing is incinerated.
Good descent, you are on axis.
Flight 671 is flying 50 knots faster than normal landing speed.
Captain did a perfect landing, kept it just left of the center line, and we were safely on the ground at a great speed, but we were on the ground.
If they don't brake soon, they will overshoot the runway. Without hydraulics, they have only the plane's emergency brake to reduce speed.
There was no anti-skid protection. That would have meant that the tires would start scuffing and bursting, which would then reduce their ability to slow down.
Stopping was the only thing that mattered.
You want both thrust reverses?
The flight engineer wanted to use reverse thrust on the 2 left engines because that was the only way he could see of slowing down.
No, cut the engines.
The first officer didn't want him to do that because that would pull the airplane off to the left of the runway.
I've just reversed engine 2.
As a compromise, they used reverse thrust on the inboard left engine, the number 2 engine, which did help reduce their galloping speed, but pulled the airplane off the runway to the left.
The aircraft did come to a halt in the mud.
We're on fire. Evacuate! Evacuate!
I realized that we were on fire, and it was burning and belching smoke and flame. We needed to get down, get out, and get away.
With 2 missing engines, a wing on fire, and no brakes, Flight 671 has landed in Istres, France, with its cargo and crew safe.
To actually have 2 of the 4 engines fall off the wing, virtually unheard of in the history of aviation.
The heroic escape from death makes headlines around the world. As French investigators arrive, they're faced with an important question. What caused 2 engines to fall off a plane?
Losing 2 engines is a huge thing. So the investigators had quite a big task to establish what had happened and, more importantly, why and how to prevent it happening again.
The damaged 707 is moved to a hangar to be examined by the BEA, France's Air Investigation Authority.
The level of damage on this aircraft was very close to looking like a total structural failure.
I've got something.
Investigators make an early discovery about the fire on board the plane.
These wires from the cable loom short-circuited. That, plus a fuel leak from near the engine 3 area, caused the fire.
Good work.
When the engines came away from the wing, they tore with them electrical wiring. Some of that wiring still had power available.
When the flaps were extended, leaking fuel made contact with live wires and ignited.
Let's get this cleaned up, get a better look at what tore the engine loose from the wing.
Investigators are counting on the plane's flight data recorder to provide more information.
Okay, let's see what it can tell us. So it looks like engines 3 and 4 were producing thrust right up until here. 10:50 a.m., 1 hour into the flight.
The FDR data reveals that both engines stopped working almost concurrently.
The flight data recorder basically showed the engines operating as normal when they left the aircraft.
To understand why two perfectly functioning engines detached from the 707's wings, investigators need to find the missing engines.
Here's the flight path.
This is where they probably fell off.
I'll send a search and recovery team out there.
"24 hours into the investigation, the engines of Flight 671 are located on a mountainside near Cédéron, France, 55 miles northeast of where the plane landed.
Investigators found the engines about 800 meters apart. That's very close.
Their locations also suggest the engines detached at almost the same time. While the team waits for the engines to be recovered, they turn to the crew for further insight.
Well, climbing to 33,000 feet to avoid some pretty bad turbulence. Suddenly, there were loud sounds. I saw engine 4 was missing.
You reported the engines missing at 2 different times. Is it possible you were mistaken?
It's possible. The harness I was wearing kept me from getting a good look out the window at first.
You said you were climbing to avoid turbulence. How bad was it?
It was severe. I wouldn't want to go through that again.
They'd flown through extremely heavy turbulence of a level not normally encountered.
So there were 2 cumulonimbus clouds here and here, and they went up past 33,000 feet.
Investigators examine the weather conditions at the time of the incident.
Looks like there was also a 90-knot jet stream over here.
They discover that Flight 671 flew through 2 weather conditions when they reached 33,000 feet.
Those 2 conditions would have generated severe turbulence.
But you'd think it could withstand the turbulence.
Did 2 colliding weather conditions tear the engines off the 707?
Let's see what the engines can tell us.
Hey, boss.
Close examination of the engines gives investigators an important new clue.
You see this dent on engine 4? Its shape and diameter match a dent on engine 3. So does this white paint.
You could tell from the shape of the damage and from transfer of white paint from one engine to the other engine that the number 3 had struck the number 4 engine and separated it.
Investigators now need to find out what caused engine 3 to detach.
Looks like a clean break of all 4 fittings.
Each engine is attached to a pylon. The pylon is then bolted to the wing using 4 large fittings. During Flight 671, all 4 fittings broke on Engine 3.
Now, 3 of the 4 fittings broke like this one. You can see from the surface they broke from stress. This mid-spar fitting is different. There's some distortion here. It likely broke from a fatigue fracture.
You could see some characteristics, surface-wise, coloration-wise, that were consistent with the fatigue cracking.
Over time, the inboard mid-spar fitting on Engine 3 was weakened because of a crack caused by metal fatigue. When it snapped off in severe turbulence, the other fittings broke too.
As a metallurgist, I want to take a closer look at these things.
Okay, let's see what we got.
To establish a detailed history of Flight 671's broken mid-spar fitting, investigators use an electron microscope to examine it.
I can see multiple arrest lines.
With each takeoff and landing, the crack grows a little bit. And it leaves a mark. And each little stress cycle makes the crack a little bigger.
These are likely from the flights the plane flew since Transair put it back in service a few weeks ago. What about before that?
As the team continues examining the cracked mid-spar fitting, they make an unusual finding.
It looks like corrosion. The plane had to have been exposed to moisture over a long period of time.
Well, looks like the previous owner had the plane in storage for 13 months prior to the incident.
Where was it stored?
In a field in England.
Steel will corrode if it's in a salty atmosphere or a very moist atmosphere. This particular aircraft was stored at airfields which weren't far from the sea.
That explains the corrosion. What about those little marks?
Near the bottom of the fitting, they discover several telltale marks.
Those are corrosion pit marks.
Corrosion pits are tiny holes that appear in metal after water has gained access to that metal and caused corrosion to take place. And the pit can be the start of a long crack.
And in this case, there were corrosion pits that grew into one crack and eventually fractured the mid-spar fitting.
So when did these pit marks start to develop?
Well, it's hard to pinpoint exactly. Given their distance from the arrest lines, it suggests that the pitting started even before the plane went into storage.
The crack doesn't occur in storage. The oxidation does. So that tells us the cracking occurred before storage. Well, probably years before storage.
These fittings were a time bomb waiting to blow.
So how did the maintenance team miss it?
This just arrived from Transair. Maintenance records.
Let's have a look.
Investigators want to know if poor maintenance on Flight 671 contributed to the crash.
You start to look at the age of the parts that fail and what was the maintenance requirements for those parts, and did they play a role in the accident.
In the 1990s, Nigerian airlines like Transair gained a reputation for poor maintenance.
For a while, Nigerian Airways were in fact banned from United Kingdom airspace.
According to this, Transair didn't do a mid-spar maintenance check.
Transair had only owned that airplane for a very small amount of time, so it's unlikely that they've performed any maintenance on it. So maybe Transair inherited the problem before it was owned by them.
Looks like the previous owner did 2 maintenance checks. One on October 10th, 1991, when the plane was in storage, and the other in May 1990, before it went into storage.
The team learns that the plane passed 2 maintenance checks in a 2-year period prior to the incident.
If the metal fatigue started before the storage, the maintenance check should have caught the problem.
There were certain cracks that should have been picked up, which weren't.
Then, 1 month into the investigation, another 707 loses an engine. The incident is similar to what happened to Flight 671. During takeoff from Miami International Airport, the number 3 engine is torn off the wing and then hits engine 4.
With the Miami accident, the pilots managed to land the aircraft safely with no one being hurt.
The NTSB investigates and discovers that a broken mid-spar fitting also caused the engine to fall off the wing.
This was perhaps history repeating itself.
Is that from the NTSB?
Yep.
French investigators review the NTSB's preliminary report, curious about the Miami plane's maintenance history.
Maintenance on the 707 in Miami was performed 328 flights before the accident.
Which is well within the 600 flight recommendation by the FAA.
They discover that the plane had also passed maintenance checks and reported no fatigue cracking or corrosion.
In both the Miami accident and the French accident, the mid-spar fitting had failed with a very similar way and had also been maintained as specified by the FAA and Boeing Aircraft Company.
Perhaps they weren't maintaining properly.
At the time, the mid-spar fittings were required to be inspected in a close visual examination. Basically, you gain access to the fitting, you wipe it off the best you can, and what you can see is what you examine.
Was there a problem with the inspection process? Investigators interview a maintenance supervisor about how engine fittings are approved for flight.
So how do you inspect the fitting?
You're supposed to carry out a close visual inspection for cracks on the exposed surfaces of the fitting.
And?
Well, cracks can start on the inside of the fitting.
So why is that a problem?
Well, it's a problem because you can't see inside unless you remove the engine and the pylon from the wing.
It's a troubling discovery. The mid-spar fitting is normally inspected by removing a panel on the pylon. But the entire fitting cannot be seen from the access panel. The engine and pylon need to be removed to check for cracks on the inside of the fitting.
Boeing did not require disassembly of the mid-spar fitting. Their risk assessment basically said it's not worth it on this old airframe.
So there could be 707s out there with cracks in this fitting that no one could see?
Yeah.
As an investigator, you always have to wonder how many more engines are going to fall off of 707s.
Listen to this.
Investigators of Flight 671 do a deep dive into the history of the Boeing 707's mid-spar fitting.
There have been reports of more than 35 cracked mid-spar fittings on the 707.
These planes are at the end of their life cycle. The 707 in Miami had flown over 50,000 hours.
The Transair 707 had flown more than 60,000 hours.
This was an old fitting on an old airplane that had been designed a very long time ago when they didn't know how these materials would age. The consequence of this, and perhaps not the best maintenance or inspection, meant that eventually this fitting just gave up.
By 1992, most 707s were considered too old to fly passengers. and were converted to freight transport.
We need to make sure this doesn't happen again.
Investigators conclude that a hidden fracture in the mid-spar fitting almost took the lives of the 5 men on Transair Flight 671. The fate of the plane is sealed when a maintenance inspection fails to catch the fatigue crack.
Ask if we can go to 3-3.
The 707 is pushed to its breaking point when 2 weather events collide.
The in-flight turbulence was the last little bit that was necessary to cause fracture. Basically, it was the last straw that held this pylon together.
The weakened mid-spar fitting finally breaks, and both engines are lost. If not for the heroics of the crew, the plane would have crashed.
The 707 is not an easy airplane to fly when everything's going well. It's a very difficult airplane to fly when things are going wrong.
I've got limited maneuvering. You dumping?
Yeah.
Captain Berglund's skill and stamina prove remarkable as he physically keeps the plane stable until landing.
From the beginning of the incident to when they finally landed on the runway, 24 minutes. 24 minutes that most pilots wouldn't have had all those things happen to him in an entire career. He was just one fantastic pilot.
Cargo 671, we have no radar contact. Say your position, please, sir.
Throughout the harrowing flight, Flight Engineer Boone troubleshoots and fixes key systems.
The flight engineer looked at his panel and came up with the solution as to why the radar wasn't working.
You turn left 180.
Okay.
Hey, you see the airfield?
And First Officer Emery's quick thinking and intuition proved vital.
Cabo 671, we have an airfield ahead. What is that airfield?
It was an absolute genius decision to land at a military base with a long runway. It shows an awful lot about the spirit of pilots and survival, that they somehow coalesce together. And they all use their own individual skills.
The BEA recommends that inspections of the current mid-spar fittings be modified to enable the detection of hidden cracks or be replaced by reinforced fittings.
The FAA decided to mandate replacement of the mid-spar fittings with a new and improved mid-spar fitting, which did not require inspections that were ineffective in the first place.
In 1992, the crew of Transair Cargo 671 received the Hugh Gordon Burge Award for Outstanding Airmanship.
This flight was a heroic achievement where the crew have recovered from a virtually impossible situation, and they deserved the awards they got.
So a lot of luck and a bit of teamwork and a bit of shouting and a bit of action, but a happy landing.